This is the 8th video supplement for CIS 343, Grand Valley State University's Programming Languages course. This video discusses first-class functions and lambdas. The code for this video will be heavily based on the two functions we implemented in the previous video. So you want to be sure that you understand this code pretty well before continuing. As a reminder, the first function was to simply find the largest integer in a list. And the second function was to search a list of player data and return the player with the highest score. The main difference between the two functions is that the parameter to the winner function was a list of lists, which means the winner function has to compare the second element of each nested list. The story is that this winner function is part of a larger program used to run a bowling tournament. For this video, we're going to continue this story by imagining that the program turns out to be very successful and another group approaches the developers for help running a golf tournament. The main difference in this situation, at least the main difference relevant to this video, is that the winner of a golf tournament is the player with the lowest score, not the highest score. Now, of course, we could just copy all this code and then turn this greater than operator into a less than operator. But as I hope you've learned in your other courses, maintaining duplicate code in this manner is difficult and error-prone. For example, anytime you fix a bug in the bowling program, you have to remember to go in and fix it in the golf program as well. What we really want is one body of code that can handle both bowling and golf. So for the sake of discussion, I'm going to show an idea that works, but has a lot of room for improvement. And that is, we're going to add a second parameter to winner that specifies the sport, and then we'll adjust the comparison to take the sport into consideration. So the main idea here is that the if statement is going to look at one of two different conditions. First one requiring that the sport be bowling, and the second one requiring that the sport be golf. And of course, golf will be looking for the lowest score. And then one other small change, if we add a second parameter, we need to remember to pass that parameter to the recursive call as well. When we call winner down here to test it, we have to specify whether we're doing a bowling comparison or a golf comparison. All right, so when we do the bowling comparison, we get the high score of 895 for Barney, and when we do the golf comparison, we get the low score of 707 for Wilma. So this clearly works, but what do you see here that should be improved? Well, first, I think it's kind of hard to read. We've got crammed into the middle of the if statement some different rules for comparison. Another aspect of that low readability is the repetition here. So this greater than clause here and the less than clause here are identical except for one character. Also, think for a minute about scalability. What would it look like if we expand our tool to support 10 sports instead of 2? And the third thing I see here is that from a software engineering standpoint, the winner function shouldn't have to know anything about the sports, either what they are or what their rules are. So one thing you will hopefully learn in your software engineering course is that ideally each function should do one small specific job. So in this case, the winner function's one job should be to search a list for the best player. But here we've added the additional jobs of defining what it means to be best for bowling, golf, and potentially other sports. Ideally, to promote the best readability and maintainability, the algorithms for defining best for each sport should be placed in a separate function with other code relating to that sport. And the winner function should be focused solely on searching the list. Any comparisons between two players should be handed off to these helper functions. For example, somewhere else in our code, we should have functions like this. These helper functions up here are in charge of knowing that a higher bowling score is better and a lower golf score is better. And then the winner function down here doesn't have to track all of those rules for all the different sports we may eventually implement. Now that we have these functions, how do we tell winner which ones to use? So one option is to replace the calls to greater than and less than with our helper functions. So this is a step in the right direction. It did address the third point, so now the winner function doesn't have inside of it the rules for being the best bowler or the best golfer. But it's still not very readable, and the winner function does have to explicitly know about every sport that the program is handling. So we still want to do even better, right? We don't want to pass the sport as a parameter. What we really want to do is pass the rules for comparing scores. Or in other words, we just want to pass the helper functions as a parameter. I mean, wouldn't it be great if you could just do something like this and pass the helper function as a parameter? So then we could get rid of the whole or and everything. The if statement need only run the chosen comparison function and pass it recursively. Much more readable. There's not repetitive code. The winner function doesn't need a list of all the sports it has to handle. It's a pretty nice system. Now, some of you may know how to do something very similar to this in C using function pointers, or in Java, perhaps using interfaces or function objects. But the really cool thing about Scheme is that this code just works. We don't have to set up function pointers. We don't have to bury this helper code in an object with a given interface. It just works. Notice what we were able to do was we were able to assign the function bowling compare or golf compare to the parameter comparison. Languages that let you do this, that let you assign functions to variables and parameters in this manner, are said to have first-class functions. In some sense, you might say that in Scheme, functions have all the rights and privileges of any other data. In contrast, functions in Java are somewhat like second-class citizens in the sense that they have names, but they don't have the privilege of being assigned to a variable or passed as a parameter. Now, some of you may be thinking, this is just like function pointers in C, and given the current state of this particular code, you'd be right. But languages that support first-class functions also allow you to have anonymous functions, whereas C does not. Before I explain the concept of an anonymous function, let me review the concept of an anonymous object. Consider this code. This code modifies the string named input twice. First, it trims off any extra white space at the beginning or end of the string, and then it converts the string to all lowercase. So when you run the code, this is the result. The string is all lowercase and has no leading or trailing white space. In the first code block, only one transformation is made per line. The first line of code runs the trim method, and then the second line of code runs the toLowercase method. And when doing this, each intermediate object is named. The result of running trim is called trimmed input, so that we can then refer to that object on the next line when calling toLowercase. In contrast, the second code block performs both modifications on the same line. First, trim is called on the string named input. That trim method returns a new string object with the leading and trailing white space removed. That returned object is never named. Instead, the code immediately calls the toLowercase function on that object. Similarly, the string returned by toLowercase is never named either. Instead, it's passed directly to the printline method. These two unnamed strings are called anonymous objects. Since these objects are immediately consumed and never used again, there's no need to name them. Instead of referring to these intermediate objects by name, the second code block takes the object immediately from where it's produced and consumes it. We can apply the same principle of anonymous objects to functions when using Scheme or other languages with first-class functions. For example, instead of writing bowling compare as a separate named function, we can simply write it inline and pass it anonymously to the winner function. In Scheme, the syntax for indicating an anonymous function is a keyword called lambda, referring to the lambda calculus that originally motivated functional programming. Likewise, we can do the same for the golf compare, except of course we are doing a less than comparison here. So did we do it right? Yes. So depending on the larger context of the program you're writing, you may want that compare function explicitly named somewhere, or you just may want to write it on the fly. One situation where programmers commonly use anonymous inline functions is when sorting a list of compound data, like our list of player data. I'm going to set up this next demo as a function, so I can refer to the list of players using this player list name instead of cluttering up the example by cutting and pasting the entire list like I did in the previous examples. So let's say I want to display my players in a sorted order. So I'll call the sort function on the player list. But in order to sort this player list, I need to specify how I want the players ordered. When given two players, I need the rules for which player should be first and which player should be second. So those rules will come as part of a function, which I'm going to define in line using a lambda. So we'll have player 1 and player 2. So let's start by simply sorting the players by score. So this function given P1 and P2 is going to return true if P1 comes first and false if P1 should come second. And since we're sorting by score, I'm just asking whether P1's score is less than P2's score. So we'll use the less than function, but we need to access the score, which is in the second position, using that helper function up above, and likewise for P2. So the orangish yellow paren closes out that lambda, closes out the sort, closes out the display. I almost forgot. In order to use the sort function, I have to import it, like using import statements in Java. So the magic words here for Kava are import srfi 95, and we now have our list in ascending order of scores. Or maybe I want to sort by player name. So I'll cut and paste that code. So now the rules for who comes first and who comes second is different. Instead of comparing the scores, I want to compare the first element of each player object. And less than only applies to numbers. If I want to compare strings, I have to use this special method. All right, now the players are in alphabetical order by name. This setup can work for sorting things in increasing or decreasing order. So if I want to display my scores in descending order, I just need to change that less than sign to a greater than sign. It would just swap the true and false when comparing two scores. So the scores should show up in the opposite order. Finally, before I wrap up, I want to quickly point out one thing that you might occasionally find useful. And that is this greater than or less than operator, like what we have here and here, is actually the name of a function. What that means is that I didn't actually need a complete lambda here to display my bowling winner and my golf winner. All I really needed to do was just pass the greater than function or the less than function as a parameter to winner. If I run that, it still gives us Barney with the highest score and Wilma with the lowest score. So if you like that shortcut, you're welcome to use it. If you find that hard to read, I certainly don't blame you. It's not a bad idea at all to code in a complete lambda like we did up here if you think that's more readable and easier to maintain when the new guy comes in and has to make some changes. So that's all for this video. The next video will show you a couple more really cool things you can do with lambdas using a concept called closures.